All right, lesson 10.5, tangents in a circle. So what is a tangent? A tangent is nothing more than a segment that intersects the circle at one point. So this right here, segment AB, is tangent. It only touches the circle at that one point. Now, what that does, that creates a right angle. So that's a right angle. Now, the reason that's important is because it forms a right triangle. So what we're doing is we're seeing if this right here is a right triangle. Now, how do we do that? We go back to one of the previous lessons. We do Pythagorean theorem. So we're checking to see if this really works. So if it is going to work, then it is tangent. If it doesn't work, then it's not tangent. So we do 12 squared plus 16 squared, and we check to see if it's equal to 20 squared. So I do that on the calculator, and I do 12 squared plus 16 squared, and I get 400. And then I do 20 squared, and I also get 400. So yes, that is tangent. Okay, let's go to the next one. Do the same thing. So in the next one, we do 9.6 squared plus 11 squared equals 14.6 squared, and we check that. So 9.6 squared plus 11 squared is 213.16. And then I'll try 14.6 squared, and that comes out to 213.16. So yes. So if they do not come out equal, then that means they're not tangent. Okay? Now, what about these? These we are assuming to be tangent. So it says, assume that lines which appear to be tangent are tangent. So in this case, we're doing Pythagorean theorem in order to find the missing segment. So here we're going to do, so there would be the right angle. That's our hypotenuse, so we make sure we set it up right. Plus 11.2 squared equals, and then that's our variable, our c, if you want to put c again. So we've done enough Pythagorean theorem to recognize this. So for 8.4 squared plus 11.2 squared is 196. And then I'm going to take the square root of both sides. So square root of 196, and I get 14. So 14 is x, or a question mark. Okay. Again, here would be our right angle. So 20 would be our hypotenuse. So in this case, it's x squared plus 12 squared equals 20 squared. So this one's a little different. So that's 144. This one I can do in my head. 400, subtract 144, minus 144. So I get x squared is 256. Then I take the square root, and I get x is 16. Okay. All right, let's continue on. This says find the perimeter of each polygon. Now, one thing to note here is that when a segment is tangent from an exterior point, so right here and right here, what I know are those are both equal. So this also would be 14. Now, I don't have to know that here only because I know that whole side's 25.4 unless I'm trying to find something else. In this case, I need to find how long that segment is. So how do I do that? I'm going to do 25.4 minus the 14. If I do that, I get 11.4. So that tells me this right here is 11.4. Now, the reason that's important is because that tells me how long that is, which would also be 11.4. Now, why do I need that? In order to find this segment. So then I do 24.1 minus 11.4. And if I do that, use the calculator here, minus 11.4, I get 12.7. So this is 12.7, which means that is 12.7. Okay. Now, why is that important? Because now I'm going to use that to find this segment. So now I'm going to do 20.3 minus 12.7. So minus 12.7, and I get 7.6. So this is 7.6, which means that's 7.6. Now, I had to go through all that in order to find this whole side right here. And that whole side is going to be 14 plus 7.6, which is 21.6. So that whole side is 21.6. Now, why is that? It wants me to find the perimeter of the whole thing. So I have to take the whole side. So I take this whole side, which is 25.4, 24.1, 20.3, and now the 21.6, and I add all those together. So I'm going to write that down here. So I got 25.4 plus 24.1 plus 20.3 plus 21.6. So if I add all those together, I should get, I got 91.4. 91.4. All right, what about this next one? Okay, let's do the same sort of thing here. So if that's 14, then that means that right there is 14. Okay, so now I'm going to do 22.3 minus 14, and that gives me 8.3. So that means this right here, oops, I meant to do that in blue. This is 8.3, which means this is 8.3. Okay, so I do 16.8 minus 8.3, and that gives me 8.5, which means this is 8.5, which means this right here is also 8.5. Now, again, the reason I need to know that is because I've got to get this whole side over here. I got to get from here all the way across. The way I do that, take 14 plus 8.5, that gives me 22.5. So now I'm going to take the 22.5, the 22.3, the 16.8, and add all those together. And that gives me 61.6. So it's not hard, it's just a lot of adding and subtracting kind of thing. All right, let's go to the next one. It's the last one we got. Excuse me. Assume that lines which appear to be tangent are tangent, and it says solve for x. So again, we have an exterior point. So that means this segment right here and this segment right here have to be equal. So our equation we're going to have here is, oops, that's 39, not 38, 39 x plus 1 equals negative 1 plus 41x. So minus 39x, it's 1 equals negative 1 plus 2x, subtract 1, or add 1, sorry, not subtract. So we get 2 equals, those are going to cancel, 2x, which means x equals 1. So in that case, we're setting this and this equal to each other. So tangents and their relationships in circles.